Hey guys, welcome to the lab on antibiotic resistance. You're going to need a handout. Make sure you have a pencil, no pens in this lab, and you can grab a highlighter from near the pond aquarium. Take a look at the learning target for this lab. We're going to model how antibiotic resistance can develop in a population over time. So I want you all to take 30 seconds here to think about this question. What is an antibiotic? And what is it used for? Please discuss this with the substitute. Okay. Okay, guys, if you said an antibiotic is used to treat infections, that was a good start. Hopefully you said it's used to treat bacterial infections because that's what we use them for. It's a form of modern medication. Remember, antibiotics can't be used to treat viral infections. We have vaccines for this, and we usually use these to prevent viral infections. So you should be with your lab partner, and we're going to do a quick intro to the lab. It's about antibiotic resistance and how that can develop. What we see in modern medicine is that when people misuse antibiotics or they don't take them for the right time or the right amount of length or dose, you can get resistance developing in the bacteria population. So join me for a quick intro. I'm going to highlight some key points on the lab. So you have a container that's filled with these chips, well, they're buttons, but it's supposed to be like these chips. So you need to start with getting this many, 13 red, 6 blue, and 1 yellow, okay? These represent harmful bacteria in a patient's body before beginning their antibiotic treatment. You could just set aside the other ones. So you're going to be modeling how you take doses of antibiotics, okay? You need to use the following key to do that. If you roll a 2, 3, 4, or 5, it was taken at the appropriate time, the bacteria was killed. You always remove 5 bacteria, and you always do this in the following order. First red, okay, then blue, and then yellow as needed. But if you roll a 1 or 6, you didn't take the antibiotic correctly, and you're not going to remove any chips, okay? The other thing we have to take in consideration is that bacteria are constantly reproducing. So if there are any particular colors still present in the patient's body after each dose, you add 1 chip of that color to the population. Don't record the numbers, simply add the chips and then roll the die to see if you take it correctly on your next turn. You're going to repeat these steps for 8 doses and complete the data table on the next page. So I'm going to give you an example of how that's going to look, okay? And I'm going to open up my lab to the data table and show you a series of rolls and how that looks. So here is my data table right at the top, okay? I have already set up my bacteria. I have my 13, 6, and 1, all right? And I have my dice ready, and I'm going to roll. So my initial one, I already have some numbers recorded, but I'm going to roll for dose number 1. Here we go. So I rolled a 4. So what do I do with that 4? Here's what I do. I put it into the data table. I rolled a 4. I always start by taking away 5, and we start with the red. So I take away the 5 reds, okay, right off the board. Now I count up the remaining bacteria. 2, 4, 6, 8. I record that in my data table. 6 and 1. Okay, I get a total number. That's 15 because I took away 5. And now here's the tricky part. I now need to use my extra ones to add 1 back in for each color. So 1 red, 1 blue, and 1 yellow. Now I don't record any numbers. That's where people always get tripped up. Now I take my dice and I roll again. So that time I rolled a 2. So now I take 5 away, set those aside. I count up my data, okay? I have a 4, now I have 7 and 2, And so that gives me 13, and that's my total. So then I would go through all the steps like that, okay? So I would just continue on. I got to make sure that I record my number that I rolled in case I make a mistake. So a 3. Again, before I roll, because I'm on camera, I forgot, I have to add those back in. So now I take away the 5, and you can see that I only have 5 reds left, so I take them all away. Now I have 0 red, 8, and 3. Okay, and now I have 11 total. All right, so before I do this, now here's the trick. Since the red is dead, they're gone. I can't make any more of those. I can't multiply those, but I have blue and I have yellow. So then I roll again. So a 2. So 2, I take away the blue. 5 now because I don't have any reds left, so I take the 5 blue away off the table. And now I count them up. So I have 0, 4, and 4, a total of 8. And I add in before I move on to the next round. There we go. I roll another 2. So I have 0. I take away my 5. Now here's the thing. I just killed off blue. Blue is dead. So now I have 0 blue, 5 there for 5 total. Now I roll again. But before I roll, I have to add in. So I roll the 5. So now I take away 5 yellows. That leaves me 0, 0, 1 yellow. 1 total. I add 1 back in. Now if I roll a 2, 3, 4, 5 this time, I'm going to kill off all my bacteria. And that's entirely possible to do within 7 doses. If I take my antibiotics correctly, I can do that. So I kill them off. I have 0. And then I would just put not available if this happened, and then just carry down my zeros. Okay? And then I use this data to create a graph. The graph's going to go something like this. Okay? I'm going to do this real quick. My biggest number is 20, so I'm going to make a scale. 2, 4, 6, 8, 10, 12. And now I'm going to graph my points. I'm just going to show you total bacteria. So I have to graph 4 lines here, but I'm going to color my total bacteria green. So you guys will have to fill in the axes labels. It gives you a scale here, but dose 0, the initial, should be a 0. So the initial number is 0, 20. So I would graph that. 1, 15, 2, 13, 3, 11. Okay, you can see I'm seeing a trend here. Bacteria populations going down. 4, 8, 5, 5. And eventually I'm going to kill them all off. 6, I only had 1. And then 7, 0, and 0. And importantly, you want to put the zeros here on this. So then I'm going to just make a line graph. I'm going to connect these points with a ruler. You should have these on your lab tables. And I'm going to make this graph, connecting all the points. Get that last one in here, right down there. A nice straight line graph. And that's my total bacteria. So now I'm going to go ahead and graph all these other ones, choosing some different colors. I would graph all the rest of these, choosing some different colors, and do it in the same way. And that's how you do the Antibiotic Resistance Lab. The last thing you have to do is to answer some questions. There will be some from the reading, which you'll have to look back to on the front page, and some using your data. So everyone's data is going to be different. So base those on your data, include data from your analysis. And that's the lab. Enjoy, guys.